A baffling uncommanded roll nearly doomed Icelandair Flight 213 after a hydraulic failure. But the true culprit was a hidden flaw that had been lurking in plain sight for weeks. This is the story of Icelandair Flight 213. On the 26th of February 2013, an Icelandair Boeing 757 was en route from Copenhagen to Keflavik. As the flight neared its conclusion, the pilots began their descent into Keflavik. They were reviewing the planned approach procedures, with the autopilot engaged. At 21:45, just as the aircraft reached the top of its descent at 10,970 meters, the pilots received an unexpected warning. A flight attendant contacted the cockpit, reporting an unusual sound. It was a steady, low-frequency hum emanating from the cabin floor, unlike anything he had ever encountered in his career. He promptly informed the flight deck of the strange phenomenon. The first officer scanned his instruments, but found no anomalies. He asked the flight attendant to pinpoint the sound's origin, but the attendant described it as pervasive, coming from all around him. Still, the instruments remained silent. Meanwhile, the senior flight attendant also reported the sound, noting it permeated the aircraft's aft section. Moments later, as the pilots communicated with air traffic control about their descent into Keflavik, they felt a subtle vibration beneath their feet. Then came their first concrete warning: right hydraulic quantity. The right-hand hydraulic system was rapidly losing fluid. Hydraulic fluid is, in essence, the lifeblood of an aircraft, crucial for operating control surfaces, extending and retracting landing gear, and other vital functions. A complete loss of hydraulics can be catastrophic. However, aircraft hydraulic systems are designed with multiple redundancies, making a total loss exceptionally rare, though not unprecedented. For instance, on final descent, we previously covered a DHL Boeing 757 that experienced a near-total hydraulic failure and executed an emergency landing. You can find links to that video at the end of this episode. The crew immediately began consulting the Quick Reference Handbook, QRH, to address the hydraulic system failure. As they worked through the checklist, another warning illuminated: right hydraulic system pressure. The flight crew faced a sobering realization. They had completely lost the right-hand hydraulic system. While not an immediate catastrophe, the aircraft was still flyable and capable of a safe landing. They understood the implications. Upon touchdown, they would be without several key components. Some spoilers: the right autopilot, the right thrust reverser, the right stabilizer trim, and the auto brake system. One might compare it to the aircraft having suffered a partial stroke. In such scenarios, runway length can be a critical factor, as reduced braking capability requires more distance. Fortunately, Keflavik's long runway mitigated this concern. As the aircraft descended, the flight crew meticulously tested its handling characteristics to understand its limitations. The crew observed that the spoilers were performing erratically. Consequently, the aircraft was vectored for runway 20 and established on the localizer. As the aircraft navigated through the fog, the pilots conducted thorough checks, aiming for the smoothest possible landing. On final approach, the pilots extended the flaps and deployed the landing gear. The aircraft vibrated as the gear lowered, but the vibration was excessive beyond what was normal. The first officer immediately noticed the aircraft beginning to bank left. At an altitude of 730 meters above the water, the plane was executing a turn entirely uncommanded by the flight deck. The pilots glanced at the EICAS, engine indicating, and crew alerting system display, expecting a disagree warning, which would indicate a discrepancy between control surface positions. To their surprise, no such warning appeared. The aircraft's left bank intensified dramatically. They had no explanation for this sudden, uncommanded maneuver. The first officer disconnected the autopilot and immediately commanded a right turn to correct the course, but the aircraft remained unresponsive. Realizing the gravity of the situation, the captain initiated a go-around. As the jet began its climb, the left bank continued to increase, eventually reaching an alarming 34 degrees. With increasing airspeed, the flaps were retracted. As the aircraft gained altitude and speed, it slowly began to respond to the pilot's right-hand control inputs. 50 seconds after the upset began, the aircraft started to level off at 1,220 meters, but its speed remained dangerously high. It quickly exceeded the maximum flap speed of 407 kilometers per hour. They now faced another critical issue. After a go-around, the standard procedure was to level off at 915 meters, but they were currently at 1,220 meters. To correct this, they pitched the aircraft down, inadvertently causing it to accelerate further during the descent. Despite being acutely aware of their rapid descent, the pilots were simultaneously discussing the perplexing uncommanded left roll, even contemplating whether their instruments were at fault. As the aircraft descended, its vertical speed peaked at 1,067 meters per minute. The pilots urgently informed ATC of their rapid descent. With the flap overspeed warning blaring, the pilots declared an emergency. The controller inquired if they could make it to the airport. The pilots replied, "Negative. We have a problem with the controls. Just a moment. We are trying to regain control." Flight 213 was in dire straits. The controller, anticipating the worst, activated the airport's full emergency response plan. As the flight crew battled to regain control, the controller advised them that they were slightly north of the short final for runway 29, an option they could consider. The captain took control, and the first officer responded to ATC. "We're going to start by regaining control of the plane. We've lost the right hydraulic system, and it behaves strangely. We are trying to regain control, and we would like to continue the present course if possible." The Icelandic air traffic controller then delivered more alarming news. They were heading directly towards a mountain range known as Blafjol. The pilots urgently needed to climb. They reduced the aircraft's speed, and to their surprise, it seemed they had regained control. The reason for this sudden stability was unclear, but it was undeniable. Cautiously, they turned the aircraft around and aligned it with the runway at Keflavik. They theorized that the control issues were linked to the flaps, and thus decided to perform the landing with only 15 degrees of flap extension. As the crew executed the approach, they requested a trauma team be ready to meet the passengers upon landing. A perfectly understandable precaution after such a harrowing experience. The aircraft landed without further incident. All 171 people on board disembarked safely, without a single scratch. So, what exactly happened? Once on the ground, technicians thoroughly inspected the aircraft to determine the cause of the nearly catastrophic events. The immediate priority was to ascertain the reason for the hydraulic system failure. The answer was relatively straightforward. A hydraulic tube within the right-hand system, located in the right wheel well, had ruptured. Examination of the tube revealed a faulty weld line, which had failed in flight, completely draining the right hydraulic system. However, this alone did not fully explain the incident. A single hydraulic system failure, while serious, does not typically render an aircraft uncontrollable. It remains fully flyable and capable of a safe landing. The investigators dug deeper, and when they analyzed the flight data recorder FDR, they uncovered a crucial detail. The FDR revealed that after the hydraulic system failed, the autopilot struggled to maintain a stable flight path. It began commanding a slight right roll to keep the aircraft level. As the plane descended and slowed, the autopilot's required right input steadily increased. Then, precisely as the aircraft leveled out to capture the localizer for the approach, the necessary right-hand deflection to maintain stability exceeded the autopilot's control authority, and the plane abruptly began to bank left. The data pointed to a far more sinister development during the descent. A spoiler on the left wing had deployed in flight without any command, causing the uncontrollable left roll that overwhelmed the autopilot. To investigate further, technicians conducted a specialized test. They powered down the aircraft's hydraulic system and attempted to manually move the spoilers. The system is designed to hold spoilers in a retracted position when hydraulic pressure is lost or depressurized. During the manual test, spoiler number 2 remained completely immobile. Spoiler number 4 was stiff but moved slightly. Spoiler number 6, however, moved with surprising ease, providing a critical clue. This confirmed that as the aircraft slowed and the flaps were extended, the number 6 spoiler on the left wing had floated upwards, generating significant drag on that wing. This imbalance progressively worsened until it exceeded the autopilot's compensatory capabilities. Consequently, the actuators for spoilers 2, 4, and 6 were sent to their manufacturer, Moog, for examination. Simultaneously, Boeing conducted simulations to determine the amount of right-hand control input required to counteract a floating number 6 spoiler. The simulation results closely matched the data recorded by the FDR. For spoiler number 4, microscopic cracks were discovered in the blocking and thermal relief valve seat. These small fissures allowed a minor hydraulic fluid leak, reducing the spoiler's effectiveness. However, on spoiler number 6, the blocking and thermal relief valve housing was completely fractured. This valve is designed to keep spoilers retracted and out of the airstream in the event of a hydraulic system failure. Crucially, this wasn't a new issue. The aircraft had completed its previous 27 flights with this valve already fractured. One might wonder, if the valve was broken for 27 flights, why did no previous incidents occur? The explanation lies in the pressurized hydraulic system itself. While operational, the hydraulic pressure forced the 2 fractured halves of the blocking and thermal relief valve housing together, essentially holding it in place and maintaining its function. However, when hydraulic pressure was lost during Flight 213, those 2 halves separated, allowing the spoiler to float up into the airstream as the flaps were extended, directly leading to this near disaster. The spoiler only deployed when the flaps were extended, because the aerodynamic forces generated by the extended flaps were strong enough to lift the unconstrained spoiler into the airstream. Although this specific failure mechanism was relatively unknown, the situation could have escalated into a far greater catastrophe had the pilots not demonstrated such exceptional airmanship. Their incredible flying saved everyone on board. Following this incident, comprehensive inspections were mandated across the entire Boeing 757 fleet to identify similar fractured valves, and additional checks were integrated into routine maintenance procedures. Stay safe.